Hi guys. Today we're going to start the next part of chapter 4, which is solving quadratic equations. So the big change in this part of our chapter 4 is going to be that instead of having an expression, which is a math problem without an equal sign in it, we're going to throw some equal signs in there. They're going to be equations. And then since we're solving, our final answer is going to be like x equals a number, something like that. We're going to learn several different ways about how to solve quadratic equations. And today we're going to learn our first way, which is solving by factoring. So just a quick refresher of our most recent test that we took. When you're factoring, there's a process that you should go through to make sure you're factoring completely. The first thing you should do is ask yourself, is there a GCF? And if there is, you should factor that out. Once you've either taken out the GCF or decided that there is no GCF, then you need to think, how large is this problem? If it's a binomial, it has two terms, you're either going to do difference of squares or sum and difference of cubes. If it is a trinomial, which means it has three terms, you're going to check for perfect square trinomials, or you can always just default to Xbox if you want. Even perfect square trinomials can be factored using Xbox. And then finally, if there's four terms, you should be using the box method. And remember, anytime I say box, I also mean or grouping. So if you prefer factoring by grouping, that's fine too. Now you need to be proficient at factoring to be able to do today's assignment. So you want to make sure that you have your factoring notes next to you. If you made your factoring book, you can have that next to you while you're working on the problems today. So again, today I'm going to throw in some equal signs, and that's going to be the major difference in how the problems look. And then by throwing in equal signs, we need to go just a couple steps further than what we were doing in our most recent test. So let's start with this first example. It's important to note on the first example that it's equal to 0, and that's going to be mandatory on these problems. They have to be equal to 0 for you to be able to solve them. So that's really important that it's equal to 0. And then once it's equal to 0, we're going to factor. Now we're only factoring the side that does not say equals 0, right? So n squared minus 16. And again, we run through our little chart. So we ask ourselves, is there a GCF? No, there's not. How big is this problem? It's a binomial, so it is a difference of squares. So I'm going to factor it using difference of squares. So n squared minus 16 turns into n plus 4 and n minus 4. And I still have my equals 0, so don't lose that, right? Make sure that's still part of the problem. And then we have this property. It's called the zero product property. And if it says that if you have two things that are multiplied together and the answer to your math problem is 0, then one of those two things has to be 0. So the only way to get an answer of 0 on a multiplication problem is if one of the numbers that you're multiplying is actually the number 0. Now, this problem that we're doing, this is a multiplication problem. When we factor, we create a multiplication problem. And so I'm multiplying n plus 4 times n minus 4, and I'm getting an answer of 0. For that to be possible, either the n plus 4 has to equal 0 or the n minus 4 has to equal 0. One of those parentheses needs to be the number 0 for the final answer to be 0. I'm not sure which parentheses is 0, so I'm just going to say, let's figure out both of them. And so our next step is to take each parentheses, each thing that's being multiplied, and create its own math problem. So I've now created two different math problems where I set each parentheses equal to 0. And then we would solve those individually. So on that first equation, I'm going to subtract 4 from each side, and I'll get n equals negative 4. And then on the second equation, I'm going to add 4 to each side, and I get n equals positive 4. Now, again, since I don't know which parentheses is actually equal to 0, both of these numbers are possible answers. And so this problem has two answers, negative 4 or maybe positive 4. And since it has two answers, we are going to write our answers in what is called a solution set. A solution set is just some curly brackets. They look like this. And then you just put your numbers in there. We usually put them in numerical order. So the negative goes first, the positive goes second. And then just don't ever use parentheses, because if you use parentheses, you're writing an ordered pair, which means that each number is a different variable. And I want to point out, right, both of these are N. So it's not like N and O, right? They're both the letter N. If you put it in parentheses, then you're saying this is one variable, but this is a different variable. And we don't want to make that mistake. So curly brackets, no parentheses. Parentheses are bad. And you'll even notice when you're working on your Delta Math that Delta Math will put in curly brackets for you. If you write a comma, it'll actually separate itself out into two separate boxes with curly brackets on the outside. All right, so that's the general what we're doing today. We're making sure that our equations are equal to 0, we're factoring completely, and then we're getting multiple answers for these problems. So let's try that second example. Now the second example is not currently equal to 0, so that's the first thing I'm going to do is I'm going to set it equal to 0. And I'm going to do that by subtracting the 7x squared. And so I'm going to take this and I'm going to move it over. When you move it over to the other side, you do have to put it in a very specific spot. You want your exponents to be in descending order, so biggest to smallest. So in this problem, I have an x to the third, an x to the first, and an x squared. This x squared, when I move it over by subtracting, I'm going to stick it right in the middle of the problem so that it goes x to the third, x squared, x to the first. And if you don't put the terms in the right order, you're not going to be able to factor it correctly. So it really is important that you're putting them, again, in descending order. Once you have the order correct, now we can start factoring. So we always start with the GCF. And this problem actually does have a GCF. All three of my terms have a letter X. So I'm going to factor that out first. Next, I'm going to keep factoring inside, especially because there's still an exponent on this variable. Like I'm going to have to keep factoring until there's no more exponents. Now this is a trinomial, so I would X box. Having factored now for what, like 2 weeks, maybe more than 2 weeks, I hope that you're getting really good at factoring. And so, you know, maybe you don't need to do the X anymore, but just in case, so we need two numbers that multiply to -18 and add to -7, and that is -9 and +2. And so here's my completely factored equation. Now, in this problem, I'm actually multiplying three things together. I'm multiplying this X, right, times this parentheses, times this other parentheses. And so since I have 1, 2, 3 letter X's, I'm actually going to get 3 answers to this question. And so we want to make sure that we're setting each letter X, each part that contains a letter X equal to 0. For the GCF, it's just X equals 0. And then that's one of our answers. And then X minus 9 equals 0. And then X plus 2 equals 0. And then on this one, I'm going to add the 9 over. On this one, I'll subtract the 2 over. And my final answer in numerical order from smallest to biggest is -2, 0, 9. One last thing I want to point out before I set you free to work on your homework is you can tell how many answers a problem is going to have by looking at the exponent. So if we look at this problem right here, it had 2 answers and my exponent was n squared. And then the second example, there were 3 answers and my exponent was x to the third. And so if you look at the largest exponent from the original question, that'll tell you exactly how many answers you should expect to have on that problem. And if we even think back to like a basic math problem, right? Something like this, right? This has an x to the first. And so I would expect to get just one answer oh, what would that be? 6, I think. And so again, you can look at your exponents to predict how many answers you should have. And then that way too, you can make sure that you're getting all the answers that you're supposed to. So that concludes today's video, and I will see you all in tomorrow's video.